internship, what is an IoT, what are embedded systems, the objectives of the project home automation system, the requirements needed, implementation of the project, screenshots of the implementation, and also conclusion to the project. Let's begin with topics learned during internship. So the internship was mainly on IoT and embedded systems. So we had an introduction to IoT, a definition for a IoT and its architecture. Coming to embedded systems, we came to know what an embedded system actually is, what are the types of embedded systems, where we are gonna use these embedded systems, and what are the main components of embedded systems. Coming to programming peripherals, we came to know about different programming peripherals like LED, Arduino Uno, CLCD, which will be used to display ADC and its use in Arduino. We have also seen some of the basic OOPS concepts of CPP. We have been taught a little bit deep in C programming from its basics, like characteristics and keywords of C programming, its basic data types like int, char, float, double, void, operators of C programming, conditional constructors and the looping concepts in C programming, arrays, pointers and lists, functions like built-in functions, user-defined functions, also storage classes, preprocessor directives and header files. Let's move on to IoT. So, what is an IoT? The Internet of Things is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. These devices range from ordinary household objects to sophisticated industrial tools. By means of low cost computing, the cloud, big data, analytics, and mobile technologies, physical things can share and collect with minimum human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and hence they cooperate. Moving on, what is an embedded system? Any combination of hardware and software which is intended to do a specific task can be collectively called as an embedded system. So, an embedded system has three parts, that is software, firmware, and a hardware. Unlike computers, embedded systems perform few specific limited tasks. Embedded devices have peripherals such as serial communication interfaces, synchronous serial communication interface, universal serial bus, multimedia cards, for example, SD cards, compact flash, and all. So, an example for embedded system would be a refrigerator or a micro oven. So, coming to the project, let's begin with the objectives of the project. So the main three objectives of the project would be controlling the garden lights in a home, temperature control system, and a water control tank to avoid the overflow of the tank or to automatically sense the state of water level in the tank and fill the tank. To begin with, controlling the garden lights. On the basis of sunlight intensity, lesser the sunlight, brighter the garden lights need to be, whereas more the sunlight, the garden lights need to be dim. Temperature control system. Switch the heater and cooler on or off remotely and switch off the heater automatically if the temperature exceeds 35 degrees Celsius, and you can also turn on the cooler to reduce the temperature. Water tank control. Switch the inlet and outlet valves on or off remotely. Switch off the inlet valve automatically if the tank fills up. Switch on the inlet valve automatically if the volume of tank drops below 2000 liters. So these are with the objectives of the project. Moving on, coming to requirements, we have software requirements and also some other requirements. Coming to software requirements, we require an Arduino IDE to code, PiximLab for simulation, VSDP, that is virtual serial device port, to configure ports for serial remote tank, and we will be using a Blink IoT app to connect the automated system through Android phone. Other requirements, we will be needed with an Arduino Uno, an LED as part of garden lights, LDR sensor to sense the brightness of the sunlight, LCD to display the parameters, temperature sensor to sense the amount of heat, and an Ethernet connection. Arduino Uno. Arduino Uno is based on Atmega 3280 microcontroller. It is easy to use compared to other boards such as the Arduino Mega board, etc. The board consists of digital and analog input or output pins, shields, and other circuits. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and an ICSP. What is an ICSP? It is an in-circuit serial programming header. It is programmed based on IDE, which stands for Integrated Development Environment, and it can run on both online as well as offline platforms. Ethernet ETH-W5500. The W5500 chip is a hardwired TCP or IP embedded system Ethernet control that provides easier internet connection to the embedded system. Here TCP stands for Transport Control Protocol and IP stands for Internet Protocol. Ethernet enables users to have the internet connectivity in their applications just by using the single chip in which TCP or IP stack 10 out of 100 Ethernet MAC and PHY embedded. It supports power down mode, supports wake on LAN over UDP, that is user datagram protocol, supports high speed serial peripheral interface SPI mode 0,3. Moving on, what is a temperature sensor? A temperature sensor is an electronic device that measures the temperature of its environment. It converts the input data into electronic data to record, monitor, or signal temperature changes. LCD. Here we are going to use an I2C LCD. 2C adapter for LCD displays based on HD44780, a most common driver for character LCDs. With this adapter, you will use only 2 pins compared to 6 or 10 when connecting LCD directly. So it is suitable for both Arduino as well as Raspberry Pi. So we are here going to use Arduino. On board, you have jumper to enable or disable LCD backlight and jumpers A1, A2, A3 to set board address on the I2C bus. An LDR sensor. An LDR is a component that has a variable resistance that changes with the light intensity that falls upon it. If the light intensity is more, the LED glows dim, whereas if the light intensity is less, the LED glows brighter. This allows them to be used in light sensing circuits. The resistance of a photoresistor decreases with increasing intensity of the light incident on it. In the other words, it exhibits photoconductivity. So now we will see the implementation of the project. As I already mentioned, the software required to code would be an Arduino IDE. So a folder is created in the name of the project and we will include all the files like home automation blink control.ino, that is the name of the project, home automation blink control, ldr.cpp, ldr.h, serialtank.cpp, serialtank.h, temperature system.cpp, temperature system.h, and a main file main.h. Loading these files in Arduino IDE, we will export compiled binary file of the .ini file. In PiximLab, we will arrange all the spare ports required like LED, LDR, LCD, temperature system, and Ethernet. Then we will load the hex file for Arduino Uno board selected in PiximLab to view the output. Also, we will use a Blink app in mobile to visualize and control the same home automation system. So when LDR is high, which indicates that the sunlight is less, then the LED glows bright. In the same way, when LDR is low, which indicates that the sunlight is more, LED glows dim. So this screenshot indicates the heater is on, that is displayed on the LCD screen. So it indicates the temperature, the volume that we will be seeing in the Blink IoT app, particularly how it will be visible, and the screen is indicating the heater off. Similarly, we have cooler on, cooler off. Yeah. So this is a serial remote tank which displays our water tank, the level of water in it, and what is the condition in it. So when the inlet valve is open, the LCD display shows the inlet is on and it also displays the volume of water in the tank. So this particular serial remote tank, which I will be showing in the demonstration of the project, indicates the water level of the tank. So when the inlet valve is open, the water starts filling. So when the inlet valve is off, it stops the filling of the water. Similarly, when the outlet valve is on, the water flows out. When the outlet valve is off, it stops the flowing of water. So here we have some of the screenshots of Blink app. So we have created few widgets like a cooler button, a heater button, a temperature gauge, a notification bar, and also we have two tabs to switch. This is for a temperature, and the tab 2 is for finding the water volume, which has an inlet valve, an outlet valve, and a volume gauge. So in the notification, we can see temperature is above 35 degrees Celsius, hence turning off the heater. This happens when the temperature is above 35 degrees Celsius and the heater offs automatically. And here we can see when the water tank is full, the inlet valve which fills the tank turns off automatically. Here notice that when the water level in the tank is below 2000 liters, as part of our objectives, the inlet valve automatically turns on so that it can fills the tank. And here we have a description on notification box where we have all the details of the events that are happening through our home automation system. So this is the Arduino IDE which I was talking about, where we have different INO files, CPP files, and H files to code our project. So INO file will be the main file that we will be executing, and through Sketch we will be exporting the compiled binary, which will be uploading as a hex file in the Pixim lab. So let me go to the Pixim lab. So this is the Pixim lab. Here we have chosen an Arduino Uno board, which we'll be using for the project. So this is the Pixim lab spare parts, where we can see all the arrangements of the uh, parts that we are using in our project. This indicates an LCD display. So this is the LED that we are having. So this is an LDR, and this is the cooler, or we can say a temperature system, and this is the Ethernet which provides connection so we can turn off or turn on the system. So these are the main components of the projects that we are going to use. We restart the Arduino. This is the button to restart. As you can see, all the values came to null, or there is no display of the values of the temperature and volume. As I told, we are going to use Blink IoT app for the automation usage through Android phone. So let me mirror my phone to you. Yeah, you can see the display of my phone here. So let me go through this Blink IoT app. Here you can see the home automation app that we have created. As I told, we have different widgets like cooler, heater. This is a temperature sensor, and we have two tabs. Tab 2 where we have inlet valve, outlet valve, and a water volume indicator. So you can create all these widget buttons and these notifications and all using settings, where you will get an option to select the widgets like buttons, slider, vertical slider, or gauge, etc. Let me on the Ethernet first, so that we can have a connection to the project and to our app. So first we will look into our temperature control system. Here we have a cooler button and a heater button to control the temperature. So if I just switch on the heater button, so the temperature increases, which we can see on both LCD display as well as in our phone. As soon as the temperature goes above 35 degrees Celsius, the heater automatically turns off. So this is one of the objective of our project, and this notification, we can see in here temperature is above 35 degrees Celsius, hence the turning off heater. So similarly, when the heater turns off automatically, the temperature gradually reduces. As you can see, it is reducing by a small factor. So if you want to reduce the temperature automatically to some large values, so you can turn on the cooler, which reduces the temperature very quickly. Next, we will look into the water tank system, that is in tab 2. So we will use a serial remote tank for the display of the water tank. So here the inlet valve is off, the same value we can see here that the inlet valve is off and the volume is 2130 liters, which is same we can see over here, 2130 liters. So when I turn on the inlet valve, the amount of volume increase of water increases in the tank, which we can see the readings over here as well as the gauge or as well as here in LCD. So when it reaches the 3000, the inlet valve automatically turned off, which is the second objective of our project, where it says when the volume of the water in the tank fills up or it is complete, the inlet valve should automatically turn off so that there is no overflow of water. So this we can also see in the notification, which indicates that the tank is full, hence disabling the inlet valve. Now let's see turning on the outlet valve what will happen. So I have switched on the outlet valve. So you can see the water volume is decreasing, and as soon as it reaches 2000 liter, as you can see it is decreasing, yeah, as soon as it reached 2000 liters and going below it, the inlet valve automatically turns on so that there will be no less water available in the tank for the usage. So the same we can see in the notification when the volume is less than 2000 liters, enabling the inlet valve. So let's move on to the conclusion of our project. Yeah, the conclusion or derivatives that we have taken through this IoT project is that using Blink IoT application and Pixim Lab simulator, I have simulated a home automation system where I have used LED temperature system, serial tank system, heater, cooler, and water tank in real time. So I came to know that CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT apps like button widgets are used to control the heater, cooler, and inlet valve as well as outlet valve. Purge widgets are used to display the temperature and volume of the water. So this was all about the project, that home automation system designed through IoT, and I would like to thank emertxe Technologies for providing me this opportunity to carry out my internships and learnings on IoT with them. Thank you.